Hello everyone. Thank you for joining our webinar today on that eternal question of how to improve SLA delivery through your existing workload automation solutions. Well, good news. Tony Beeston, today's presenter, is here to guide us. I'm Kitty Anderson of Broadcom Automation, and I'll be your host of today's webinar. Just a couple of things before we get started. Since this is a public webinar, all lines will be muted. We do encourage your questions. Please use the questions area on the side panel in BrightTalk. We will absolutely make time for those at the end. The recording of this webinar will be available through the same link you joined today and can be shared with colleagues and associates. So I think we're now ready to get started. It's with pleasure that I introduce you to Tony Beeston. Tony is a valued member of our product marketing team and a subject matter expert in workload automation and automation intelligence. Over to you, Tony.
Thank you, Kitty, and welcome to all of you. I've spent the last 20 years working in automation, firstly as a consultant delivering modern automation to companies around the world, then as a pre-sales consultant advising prospective clients on our solution and the benefits to their business. And more recently, I've moved into product marketing, working both with customers and analysts in driving forward the story of automation and its impact on businesses. Today, I'm going to be talking about automation intelligence and how we can improve the delivery of our SLAs to our business. Importantly, how we can remove many of the risks we have today in our operating environment and allowing us to deliver the high-quality services that our business demand and deserve. This session is not going to get into the weeds of a solution, the buttons to press, etc. But it will use multiple customers to show that it can be done, that it's easy to adopt, although often unique to each company, and the results that can be achieved. But before those customer outcomes, I want to start with what we might be missing from our existing automation solutions and why we might need this automation intelligence. I'll also talk about many of the mitigations we put in place, so you might see some of those in your own operating procedures. The commercial enterprise solutions on the market today vary tremendously in what they provide to manage our SLAs. What they provide is typically limited to workload under their control, and so miss much of what can impact our SLAs. SLA definition is often quite simplistic. This job or jobs must start by, so a waypoint notification to turn around and say we've got to a certain point, or this job must complete by this time frame to move forward. Often we're unable to include as dependencies or as notifications as part of the process things that aren't in the scheduler, maybe non-workload processing, workload from other technologies or even business and technical events that need to occur and can delay processing that effectively then hits an SLA. Forecasting varies tremendously from product to product. It can be, in some instances, relatively simplistic to the point of becoming a little untrustworthy. If you're using simple averages over the last 50, 100 executions, that's quite a simplistic model to be using because, as we know, no two runs of any schedule are really the same in any particular way. But the short and long-term projections can also be quite inaccurate. Again, if you start plotting that particular projection of averages out and you start projecting it forward, you get more and more inaccurate as you're going forward. It gives us a guide, but there's much better ways of being able to do these types of things. And because of that, we often end up with alert storms that can be created. They can be from, a lot of them from false alarms, especially if we're using a lot of waypoint notifications to say, we should have reached job AB6 by 3 in the morning, and it starts firing off alerts because we haven't reached that job. They can actually be false alarms. What we actually want to do is actually not just check the waypoint, we actually want to know the projection of everything that's going to go on in the the model of the execution that's going on at that particular time. And it can also be quite difficult to see what's causing the problem. Now, obviously, if you've got a job failure, that's a pretty obvious point that, yes, that's what's going on. But quite often, the missing of an SLA is much more subtle than that. It's not just the fact of a job failed and, you know, if you don't get this stuff restarted by 2 o'clock in the morning, you're going to miss your SLA. Quite often, it's actually a gradual increase in execution times across a whole series of processes, and that can also create a different set of jobs that must complete to actually make the SLA that's going on. So it can be quite difficult to identify what can I impact to actually help resolve the problem when it's not just simply a job failure. And another big area, you know, prior to my 20 years in automation, I used to work in operations. So workload changes, yes, we have to accommodate workload changes on a very regular basis. Some of them are short term, some of them are longer term. And frequently, what seems quite a minor scheduling change actually has quite dramatic impacts to unforeseen SLAs that we've got to deliver. So you know, we try and model these as best we can. We try to do execution and test runs of something. But if I've got an 8-hour batch process that's running, to test it, it takes me 8 hours. So quite often, I need to put it in and hope. And many of these things just make it harder to prevent these SLA breaches on our processing. Now, you'll see the word critical quite often because, to be honest, yeah, we have SLAs and we have OLAs, now operational level agreements. Now, any SLA to the business must be critical by its definition. If not, it's really a desire of what we want, and it may be supporting a KPI, in which case it's really an OLA. Before talking about EMA, I actually remember several years ago, Forrester, another research analyst company that you're probably aware of, producing a paper that actually showed that companies often relied on between 4 and 10 scheduling technologies simply to complete their #1 business process. Not all of them, you know, not how many I use, just that one. And that's an awful lot of handing off and controlling that needs to go on. And it includes scheduling that comes from the likes of, you know, relational databases, data warehousing tools, also many of our other applications that we've got within our stack, but also from operating system schedulers, you know, Windows Task Scheduler and Chrome, as well as our corporate enterprise workload automation tools. So it's a mix of everything that's going on. But if we focus back on the enterprise workload tools, EMA, as they reported in their survey, that 60% of large organizations are actually using these solutions from multiple vendors, often acquired through M&A activity or simply different tool choices, or it could be technology, mainframe and distributed, it frequently occurs on. And although we may have thought of standardizing them, I've certainly been in that world many times, and none of us want to go through a big bag scheduler migration to go and do that. 3/4 of those companies have their critical business processes spanning these commercial enterprise solutions, and 1/3 of those reported significant issues in delivering those services through that technology. So really, the only purpose of this slide is really as evidence that even with 2 enterprise-class workload solutions, companies recognize the challenge. If we add the other scheduling technologies I mentioned before, the problem just becomes a little bit more complex about what's going on. Now, I want to be really clear here. I am not suggesting changing these tools. Those migration projects are often high cost, high risk for the business, as the solutions themselves are keeping the lights on in our organization. So what we do, well, what everybody does, is we maintain the status quo, and we expend resources on trying to mitigate the risks that this situation effectively creates for us. And what are they? Well, most organizations tie up staff to more closely monitor these processes, setting up, you know, standard operating procedures, SOPs, to mitigate the impact and try to return to normal service as soon as possible. We get really, really good at firefighting. But the lack of visibility across the scheduling technologies, or in fact it could be a single scheduling technology where the business process is really complex, held in multiple workflows. It makes it difficult to visualize the steps I need to get through. This often results in inefficiencies in operations itself. It opens us up to much more human error because we are only human. As experts as we are in operations, we can't stop that from occurring. And ultimately, we're delaying in delivering these results. Now remember, when everything runs perfectly, we don't have a problem, that's okay. So we're really here focusing on when something unusual, abnormal, or growth patterns are going to show things that comes up. And as I mentioned before, another area that has significant impact to our ability to deliver is when we need to make scheduling changes. Now, I used to work in ops. We change them on a very regular basis, whether they're short-term changes. They tend to be less problematic because we tend to be, please don't run this for the next 2 weeks, or where we're needing to add more things in. This same lack of visibility means that it's difficult to understand what the impact of, as I said, what could be a very, very minor scheduling change. And I've put things live in the past, and I'm sure many of you have done before, turn around and say, yeah, that would be fine. And then we have a problem in delivering something, and we go, oh wow, I didn't realise that would happen. It's one of those things. It's so small, of course that'll be okay. Effectively, having multiple islands of automation, whether it's multiple instances, single vendor, multiple vendors, disconnected automation, across mainframe and distributed, they're all making our life harder to deliver what the business requires. And I mentioned that simply standardizing scheduling is not always the answer. There are times when it's time to change scheduler, yes, but this isn't one of them. There may be lots of other more major things going on. Changing that scheduler, I've been there. I've done them as a supplier of the scheduling tool. I've been the consumer and operator taking on a new one. The cost, but it's more the risk and the time that it takes to go and do everything. What Workload Automation Intelligence offers is the ability to connect all those multiple scheduling engines from several different vendors to be able to understand and monitor the delivery of SLAs to the business, connecting all the existing investments, but now providing the visibility across all of our infrastructure to deliver those business services better. It also will give us a standardized way of doing analytics, because as we all know, even calculating average runtime of a job is different from vendor to vendor, product to product, vendor to vendor, etc. So across those automation engines, as I said, from mainframe to distributed, from Broadcom, IBM, Tidal, and soon BMC, as well as any custom automation solutions you might have, as well as any business events you might want to feed in. So being able to feed more data in from the black box systems you have yourself. Automation intelligence is designed to alleviate those challenges and actually allow us to deliver better. Firstly, the obvious. It combines the data across those engines and gives us a single point of view of what's going on. We also get a standardization of what that data looks like. If we're in AutoSys, we've got a box and we've got a job. If we're in IWSz, we have different terminology. In Broadcom, again, different terminology. So it gives us a standardized set of data that's held for the very long term. So that actually allows us better capabilities, and we can start to release the concept of machine learning or artificial intelligence to look at the models and the executions over a long period of time about what's going on. It allows me very, very easily to define the SLA I've agreed with the business. If we take the most simplistic point, invariably we've got something at the very end that's the thing that we need to deliver. It produces a report where you can actually define the SLA on that. That's where you turn around and say, here, that's what I need by 7 o'clock in the morning. What automation intelligence then is, actually then discovers all the dependencies that are needed through your existing technologies to actually deliver that SLA, including connecting back to mainframe processing that's needed. CA7 is doing a data set drop, it'll actually discover that you're waiting for the data set drop and say, oh, that's a dependency, therefore we've got dependency processing going through that. If you have very unique processing that you want to create yourself, you can also add any specific events that are part of it to it as well. So it gives us much greater insight into the workload being run. And that also allows us to make changes to improve the delivery with confidence of the outcome before we apply it, because now we have everything that's going on, what is being delivered, it's collecting the data for the long term. I can actually turn around and say, well, if I did this, what would happen? Or I need to improve this flow because I'm starting to get close to my time. I can actually start turning and focusing on where do I need to make efforts to change it, and also what, if I change this, will it have an impact to the delivery? So, through the critical path of any of the things that's going on. But also, when things do go wrong, and remember, things will always go wrong, we can't eliminate any problem ever occurring, it provides that dynamic critical path across all of that workload, so determining the impact SLA delivery. So if I go back to my mainframe and my distributed, my mainframe job is running longer than it should be, and actually in distributed it's discovered that there's a dependency that's then going to hit an SLA because there's an SLA in that processing. It will actually start to alert to that because it can see that the mainframe job's running. It could be an unrelated job on the critical path for something else that needs to create an event that something else needs to wait for. So we can laser focus our efforts into where it will actually impact what we're going to deliver, and we lose the noise of everything else that's running. The picture on the screen is pretty simplistic. Most of our processing is hundreds, if not thousands, of tasks that need to occur. Trying to see the wood for the trees can sometimes be a challenge. But also that critical path is incredibly dynamic. It's not static in any way, shape or form. So it allows us to monitor not just by the jobs that are being scheduled, that's great for operations, but we can also by the business process that we're undertaking. So we can create that higher level view that obviously could be used in operations, so replenishment is running okay, but we can also now share it with our stakeholders in the wider business and turn around and say, hey, you can see the status of the processes that are going on, you can see the history of what's going on. We're not going to let you take actions and react to anything, but you can at least be informed of what's going on. And really importantly, it's always monitoring for the outcome of the SLA. So it's constantly predicting the outcome. So there's no waiting for an event. I don't need a job end event or a job start event to do a calculation. It's actually doing it in real time. So if a job hung in the middle, yes, it will realize that because it'll see the runtime to start doing predictions and move things out. It also intelligently predicts going forward. So as I said, no two runs are really the same. So, my process flow is running and it's constantly trying to see the pattern of execution I've got here and which pattern in my history that I've ever seen before does this best fit. And therefore, I will use the runtimes I saw for that to determine when I think something's going to happen. So it tries to get very process specific. So, if we're in a Black Friday processing window of what's going on, it's going to be modeling that against previous Black Fridays automatically. It won't need to be told about that. It will turn around and say, hey, this looks like a Black Friday event. That's what happens in a Black Friday. Let's see what's going on. So with that risk being predicted in advance, frequently it will actually give you sufficient time to resolve the issue before it actually impacts the business. And lastly, it allows us to model potential changes across these environments to understand the impact to SLAs without needing to run all of the workload. So let's say I'm sitting there in AutoSys, I can present a GIL file from AutoSys into the system, which is the boxes and all the jobs that are going to run with the relevant changes that I'm going to do, and it will actually take the previous models and turn around and say this is what the impact is to the SLA. So I can actually see, will things be later, will they still be within SLA, are they getting closer to the SLA, what's going on, before I even present it to a scheduling engine. So a lot of good things that it can do. But, what do we do now? If we don't do anything, then we're obviously maintaining the status quo that I talked about. And we will impact the efficiency across the entire business. Because an SLA breach, we often turn around and say, oh, yeah, we failed again. but it actually impacts the operating model of the entire enterprise. We could be, in fact, impacting thousands of people and therefore creating inefficiencies in them. You know, whether they're taking actions on data that's actually incorrect, or whether it's they're waiting for data to come in, you know, both instances impact them. So to attempt to mitigate this, we'll continue to invest more capital, which not only increases our cost of operation, but it takes those resources, because remember, these people, you know, these are the best of the best of the best. You know, I used to work in operations. We're smart cookies. We want them actually looking at how can we push the company forward? How can we improve? How can we get better? How can we adopt new innovations? So if we're consuming the resources in our run mode, it takes it away from that. And that drag on operations can therefore impact the potential to capture for the business more income through the use of increased innovation. As EMA research highlighted, and this is on one of their published papers, it's a quote that I pulled straight out of it, our workload automation data is a rich source of malleable information that should, and notice the word should, be used to advise on a broad array of decision making. At the moment, the data exists within the tools that we're using, but we can't necessarily attribute the intelligence, and maybe some of the ML, the AI around that, to actually turn around and say, where does this fit, what's this going to do, and what's going on. But it absolutely should be. So, as I've been talking, there is a way forward without having to change all the tools we rely on so much today, and that is this automation intelligence. Now, again, from EMA, they undertook a survey. They took it on our behalf because they were talking to customers about using automation intelligence, and their survey showed that it is impossible to improve. Over half of the companies adopting it found that their management of automation and the SLAs that it delivered got significantly better. They could see it. Obviously, it's no magic bullet. It can't stop you ever having an SLA breach. That's an impossible ask, because you never know what the problem is that's going to cause it. More importantly, these organizations actually discovered previously unseen threats to delivering their SLAs. They found the weak points within all of their schedules because they started to be able to see crossing all of these different technologies. And so they were actually able to stop these things from ever sort of rearing up their head and impacting the business. Now, I wanted to add a little more color to EMA's research, so I'm actually going to go through some of our customer stories so you can see what they've done. They come from a whole mixed bag of organizations around. There are some common themes, so there will be a little bit of repetition within here, but I've tried to avoid that where I can. So our first customer is in financial services. Like many customers, they suddenly become shy when you start turning around and saying, can we say who these people are, etc. You all get shy. There's no problems with that. But they're in financial services. They used a single workload automation solution, but they had multiple instances of that solution running. And that's, again, quite a common environment in large environments. You know, I don't have everything running in a single system. I've actually got multiple systems around there. Their business processes were pretty complex, often containing, you know, in the thousands of individual jobs to complete the particular business process. A lack of visibility across those scheduling instances was their biggest change because the process spanned across them. It wasn't seeing the jobs under their control. Obviously, it's an enterprise class scheduler. I can see the jobs under my control, but it was actually how they all relate to each other, their criticality of jobs in delivering the core SLAs to the business. That's where the challenge was, not an operating model. I can bring up 3 monitors if I've got 3 instances, and I'm going to watch them. And obviously, I'm going to get alerts from all of them for any failures. So this was more about being able to understand the interrelationship between them. When problems and delays did occur, they lacked the ability to understand the impact to those SLAs, but also in being able to predict when things would be back to normal. So, you know, it's the classic question. You get a phone call from the user and says, right, when are you delivering this? And it's like, well, it's saying this at the moment. So they were uncomfortable with, you know, just adding all the averages back on of what things should take to run when it moves forward, because it's obviously in a different model. It's taking longer than it should, these types of things. one of their key processes, and it was the key process for them, if it was delayed, it would stop their traders from being able to effectively trade at the market open. This had a risk potential of millions of dollars, but it also had an impact on their brand and to lose custom, because if they're not able to trade to the absolute best they could obviously still place trades, but they were placing them a little bit blinded to their positions. Obviously, their competitors, customers are going to move to their competitors. They have two main areas of improvement. The ability to simulate the impact of a schedule change on all of the SLAs before it went anywhere close to a scheduler. That was key to them. Again, long-running processes, if I want to change the scheduler, I can't run the entire schedule to go and see what the impact of this will be. I need to just visualize it instantaneously. Is there an impact to it? Yes, no, be able to progress and move forward. Like most operations teams, workload is very, very complex. And what often seemed, an insignificant job ad actually ended up having quite dramatic impacts in the delivery of a much later down SLA, not necessarily within the same flow of jobs, but actually another one that actually had dependencies that had to wait for other later steps. But also, with the detailed analytics of what runs today and that modeling capability, they were able to safely make changes to reduce the batch cycles, deliver earlier than the business was ever even thinking that they wanted to ask for. Yeah. So actually being able to go through, model and turn around and say, well, if we do this, 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 and this is what the impact will be on it. But they could also then run through multiple scenarios. They're in financial services, so Black Friday doesn't apply to them. But if you're in retail, okay, what will this do on Black Friday? What will this do on the New Year sales if we're in the UK? You can actually see the different models that it would be effective in. And that was never available to them before. When they did make changes, there was always a fear of the unforeseen. So they used to watch a lot closer. And again, in operations, as one of the operations notes, keep an eye on process B tonight, just keep a closer eye on it, see what's going on. The outcome for them, avoidance on those millions of dollars of risk, it's obviously the headline. Of course it is for them. But now, inside operations, they actually now have the visibility and the control over everything that's being delivered. And they feel that they can now make changes with confidence to the business, either to adopt new technologies or for just the general improvement. So they feel that they're offering a much more consistent and better service and becoming a better corporate citizen back to the rest of the business. This investment bank, like many large organizations, had different scheduling engines across mainframe and distributed. Probably the most common that I see, because that's normal. And that created for them two sources of truth when it came to the delivery of services, because the processing obviously spanned across them, but for many of their SLAs that they have defined. And they had no ability to monitor what was happening from a business perspective, with the workload being controlled over those two engines. They had a lot of waypoint notifications to try to give them a bit more confidence of, we're in the right ballpark of where we should have been, but nobody could actually bring up a single place and turn around and say, here's where we are, here's where we're predicting to get to, and here's what the SLA is that we've agreed, and this is the model of execution that it's actually running in. So by having that single point of view across these engines and that centralized analytics, and what it was meaning from the SLA perspective, actually dramatically shortened their mean time to repair when an issue did actually occur. So when these problems do pop up, their MTTR is reduced because they can immediately pinpoint where, if I make changes here, it will have the impact, and this is the impact it will have. Obviously, I then need to go into the scheduler that's driving that and actually control it. It's not a centralized controller of all schedulers. It is the ability to monitor and see what's going on with all of these and alert and tell us what's going on. The analytics and the machine learning behind that is critical because, as I mentioned before, no two batch runs are really identical. And the system learns which of the previous patterns of execution this run best fits. And then it projects that based on that information from that model going forward. So that earlier alerting to the potential breaches also reduced the number of SLA issues that actually ended up hitting the business. They actually gained the time to remediate before the business was done. Ultimately, they freed resources and operations to work on much more strategic projects, which is what we want to do. But they began delivering their SLA critical processing even earlier to the business. The things that needed to be there at 7 could be there at 5. We have plenty of bandwidth. And as we all know in operations, scheduling is always changing. So if I can have a spare hour, I would love a spare hour, please, because over time I'm going to be adding more and more things in there. This insurance company, like the previous customer, operated mainframe and distributed environments that were different. They could not determine with any accuracy the impact of a change to an SLA. But they also needed to be able to apply changes to scheduling at very short term. I would actually say it was almost near real-time changes to the scheduler. I don't think I've seen an organization that needed to apply as many changes directly into a production scheduler because of the way their business works. And that combination was a serious problem to consistently deliver the SLA the business demanded, but also be able to adopt and accept all of these changes that were required by the business. The single point of view across the engines and that ability to accurately predict the impact, that was the biggest thing for them. Overall, they got much better at delivering the service, far fewer SLA breaches going on, but also in predicting to the business on how late something would be if it was beyond their control to deliver on time. And this is one of the key things. I remember taking the call and it's like, when will it be ready? And it's like you're looking at the screen and going, I don't really believe the time that thing's giving me. So actually have more accuracy because of finding the model of the execution is working in or projecting forward the same activities going forward really gives us that confidence of I'm actually much more, I feel that I'm good with that. And those, being able to apply those near real-time schedule changes, again, it de-risks the operations environment for them. So last customer here, so I only picked a few of them. This bank consumed workload automation on distributed from multiple different vendors. Like a lot of organizations, they had pockets of different schedulers in different places for different reasons. Interestingly, this bank, they continuously work to improve business resilience by maintaining these critical business functions, minimizing the risk, financial risk, both to itself and its clients. So optimization of its workload environment is a key part of that strategy. So they have, whereas we might have a periodic project to try to improve scheduling, they had a perpetual project that was always looking at what can we do to improve the automation and how we get workload that's running through it. And since many of their day-to-day business activities rely heavily on automated workload processing, any disruptions to the workload environment directly impacted multiple service levels and the ability for the business to be able to complete transactions and earn revenue. So that was their hyper focus was on constant improvement. However, with that lack of visibility across those two vendors and also a disparity in how those two vendors projected the information that they were under their control, how they calculated average expected run times, how they projected future execution models, and how they exported them to be able to put them together. That made it really difficult to actually predict with any confidence what might happen. So they couldn't predict impacts to their SLAs. There was very limited visibility of cross dependencies. It was effectively operational notes, scheduler to scheduler, about what's going on. So quite often they felt, when we talked to them, they felt that they were running blind in that instance. It's something that just, this happens, it happens somewhere, and then we can start, but I don't know where the thing that happens. That particular person didn't have the visibility they wanted. So it was this, single point of view, essential for managing those critical processes that spanned multiple vendors. And remember, when I talked at the beginning, I've focused on multiple vendors. Several of these have other scheduling solutions, maybe from their relational databases, maybe from other applications. One of them has a complete black box system that there's an event that goes in and there's an event that comes out, and they need to wait for the event on the way out. Being able to model and include those other events through standard raising of event triggers. But they were able to reduce significantly the human capital to operate the environment. But more importantly, it allowed them to become much more proactive in delivering the services. They gained the controls over their own world. Yeah, having enough time from that identification to resolve before the business really knew there was an issue. So in addition to operating for today, those advanced analytics and future projections toward workload meant they can plan for better improvements in the delivery for the future. Seeing in advance how this would play out, what it would look like, what would happen, it gave them the confidence of being able to say, yes, this is what will happen. So those were 4 customers. Obviously, I do work at Broadcom, so yeah, our workload automation intelligence. It is the leading supplier in the market, and it's recognized by all the analyst firms that are out there as providing significant value to businesses. We are the sole provider of this type of technology, allowing to bring in, mainframe scheduling, distributed scheduling, having a single point of view, coming in from multiple different vendors, and also allowing other events and data to flow in from custom scheduling solutions that you have, and allowing that single point of view and SLA management that spans all of that. Not only do analysts highly rate the solution, and there's some nice papers on our website where you can see what they talk about, but it's already in use in many of the most complex operating environments for some of the most demanding enterprises out there. These people are running the big ticket item operations environments where everything is super critical, and they're already using it, and they will happily reference about doing those things. So before we get to questions, the standard corporate closing, Broadcom provides significant advantages to your organization when it comes to automation. We are the leading provider of intelligent automation, supported by a comprehensive ecosystem to expand your automation policies right across the business. Scales, it won't let you down. Evolving automation with analytics and machine learning that extend right across the organization, supporting not only traditional operations, but your DevOps environments, your big data, your cloud programs, and allows you to increase the adoption of automation in all areas of your business with complete confidence. Now, with all that said, I'd like to hand back to Kitty for any questions you may have raised. Kitty.
Thank you, Tony. Very good. We actually do have a couple of questions, so thank you, everyone. Keep them coming. Tony, the first is a combination question, I guess. Or should I say, will automation intelligence, is it specific to workload automation only, or will release automation have integration available? And that's a kind of combo question, because the second question was, will atomic workload automation and AutoSys both have integration with automation intelligence? So I guess they're looking to find out where the integration will happen.
That's no problem.
Thank you.
I'll answer the first one. So it is not only for workload automation. It is for release automation. I'm a former operator. I said that right at the beginning. If you get down to the crux of release automation, you end up orchestrating a whole series of tasks and jobs that you need to run. Those are jobs. So automation intelligence applies as much to release automation as it does to workload automation. Now, obviously, it needs to be integrated into the technologies that's going on. You saw ones before. So, like the atomic technology, yes, we're actually just opening our beta program for atomic workload automation to our atomic customers, and notifications will be going out very soon. If any of you are actually interested in that, if you turn around and say, I am interested in that in the chat window, then Kitty, after this, actually gets who you were, but who asked the question, and she can enter details on. That is being released. It will be just after the summer, but the beta program is, I think they're actually having the first release beginning of July for the beta program customers for atomic automation. AutoSys is already there. Yeah, that has been there for an awful long time. The other ones that are already there are obviously CA7 Jobtrac on the mainframe from our perspective, IBM, so IWSz on the mainframe, also IWSz in the distributed world, and Tidal. And we're also in a similar sort of time frame to Atomic, although it might be a month later. We're in the process of building out the BMC one as we speak at the moment. So I think I've answered both of those questions at the same time.
Thank you. Great. Guys, you got a couple more.
Yep.
How long will it take to implement this level of SLA management?
It is, first of all, that is a great question, but you've also asked me a question of how long is a piece of string. And I'm sure the person who asked it is aware of that. However, yeah, I've been a consultant for many years before I started working in here. This technology is actually really quick and really easy to put in because it's not controlling your workload schedulers. It takes a feed. So it's a fact of you install the software, you'll have that done in a day. Yeah, easy, no problems whatsoever. You stand it up, you connect it to your schedulers that you've got at the moment. There are connectors. That's a configuration process. To be honest, I'll do that in the same day. Okay, so you're there. To define an SLA, you need to identify, once you've done that, all of the jobs and all of the processes that you are running on any of the schedules that you're doing now exist within Automation Intelligence. So now I can simply pick the things that I wish to define my SLA on, which again is a matter of picking it, setting rules for what the SLA is. So that's pretty quick, okay? But remember, it also needs to have had some past data to be able to do really good projections. So that's defined, it's up and running, you're sorted. But you are going to need a bit more than that because you do need to collect some data for its projections to get better. The more data it gets, the longer it goes. And as we know, depending on the scheduler that we're using out there, we might be holding as short a week's worth of historical data within our main system. Well, that means it's only got a week's worth of data so far. You know, if you're using Atomic, that's fine. You might have it set to a year, 2 years, whatever. But different products have different ranges, so it needs to collect more data. Yeah, how long is a piece of string? A piece of string is, yeah, a week to 2 weeks, you're done. You need more data to be able to, as it collects more data, it gets more and more valuable because it gets more and more accurate for you.
Sounds good, Tony.
Mm-hmm.
Another question. Does this work with CAESP? And this person apologize. No apology necessary. We'll answer all questions.
None whatsoever. ESP did exist on my earlier slide. ESP is also being developed by, as you're probably aware, that's the mainframe division within Broadcom. They are actively working on that at this moment in time. The original expectation was it was going to come out exactly the same time frame as Atomic. It seems that's not the case. It's going to be a month later than Atomic. That's going on. So I didn't call it out specifically. It is on the fast track because it's one of the products we obviously own ourselves. But the ESP teams have already started the work on providing APIs that can make the connection. There is a standard connector in Automation Intelligence that collects this data. So it's a matter of getting the data into the format and off it can go and run. My expectation is it's going to be the other side of the summer. My expectation at the moment is it's going to be a month after that. I will ask Kitty to send me your details because you'll actually know about ESP, and I'll keep you in the loop of anything else that's going on for that. Because there will be a beta program for that as well.
Yeah, we'll do that, Tony. Another couple. Can data be fed into our corporate data warehouse?
Ah, yes. So I'm assuming you've already made the investment. You might have, you've got schedules in different places. You're already extracting data, and you're probably already putting it into a data lake of some description that you've already got. Yes, you can take the data. This data can feed directly from here, including the calculations that it's made in, and can be presented into your own data lake, your own corporate data warehouse, as you wish to.
All right, good. And we do have one more.
Yep.
How is this prediction better than my existing scheduler?
Again, Good questions. Right, I mentioned this a couple of times before. So yeah, different solutions, and I'm not going to go through each of the different solutions that I've ever worked with and say this is how it calculates what's going to go on. They all do it slightly differently. You know, some of them use an average runtime, some of them use some standard deviation on that. All of them have a calculation about what's going on. The difference is really the fact of enhancing and using this, the AI ML component of being able to find out what this execution, what past execution does it model in. So that's why I talked about needing the history about what's going on, to be able to predict the future based on what that one. So immediately, your Black Friday run looks like a Black Friday run. If you was to turn around and say, what's it going to look like? It immediately turn around and say, hey, that execution model looks like a Black Friday run. It's not calling it that. It's just saying it's this model. And therefore, it uses the data that it saw from that to predict out the future, not just of the job that's running, but all of the other jobs that are running. Okay. So again, that's the reason why the prediction is not necessarily a better prediction on every individual separate job. It's on the prediction of the SLA, which is the combination of everything in the critical path.
Great. And as Tony said, I will share individual feedback and questions with Tony so he could follow up as necessary, whether it be right away or down the line. So again, thank you, Tony. Thanks for a great presentation as always. And to our audience, thank you for joining. Thanks for sharing your time with us. And we hope Tony's ideas got you thinking and provided lots of possible improvement scenarios. We appreciate your time spent here today with Broadcom Automation. And all that's left for me to do is wish you all a very pleasant rest of your day. Thank you. This presentation will now end.